What is Internet of Things? Why Internet of Things? Key features of Internet of Things. IoT advantages. IoT disadvantages. Internet of Things platforms and protocols. And IoT cloud. And many more. So the intro of IoT is. A short definition of IoT is the combination of Internet and Things. That's why it's called Internet of Things. Where Internet means virtual network for collecting and storing information. And things means physical network like devices, sensors, actuators. So we can say that IoT is the combination of embedded system and Internet. What is Internet of Things? Internet of Things, or IoT, is an architecture that comprises specialized hardware boards, software systems, web API, protocols which together creates a seamless environment, which allows smart embedded devices to be connected to Internet such that sensor data can be accessed and control system can be triggered over Internet. Also, devices could be connected to Internet using various means like Wi-Fi, Ethernet and so on. Furthermore, devices may not need to be connected to Internet independently, rather a cluster of devices could be created. For example, a sensor network, and the base station or the cluster head could be connected to Internet. This leads to more abstract architecture for communication protocols ranges from high level to low level. Now the next topic is why IoT is needed. Assume that a lady wearing a high-tech spectacle walks into her kitchen. The moment she opens the door of her refrigerator, the refrigerator tells her spectacles that there is no more milk. Then, the refrigerator or the spectacles sends a tweet to her husband asking him to pick a carton milk on his way home. When her husband reaches home, his car talks to the garage door which automatically opens. Hurrying in to catch the cricket game on TV. He forgets to lock the car. When he switches on the TV, it notifies him about the unlocked car. Does it sound like a sci-fi movie to you? Wait for a few years and it will become reality. In next few years, you will most definitely see changes, which will dramatic impact in your life. This is what we call Internet of Things. Another example of Internet of Things. Imagine a moment, living in a house, where everything is connected. As soon as you wake up, your connected bed or pillow tells the TV to switch on, so you can watch the morning news. Meanwhile, the coffee maker goes to work, and depending on how well you slept, the machine adjusts how strong your coffee will be. When you get to the shower, the water will be set to the temperature, based on how hot or cold the weather is. And when you go to your bathroom mirror, it tells you if you need shave, and reminds you to brush your teeth. When you get to the closet, the mirror helps you pick out your outfit for the day, taking into account when you are headed to. Then before you head out, a screen or a window on your door reminds you of the things you need to bring, and issues your schedule for the day based on the data in your smartphone or tablet. This is the future. This is Internet of Things. History of Internet of Things. The phrase Internet of Things was first coined by technologist Kevin Ashton way back in 1999. When he used it to describe how data captured by humans would lead to a revolution once computers started generating and collecting data by themselves, without any human input. Since then, the vision of the Internet of Things has evolved due to a convergence of multiple technologies, ranging from wireless communication to the Internet and from embedded systems to micro-electromechanical systems. IoT key features. The most important features of IoT include artificial intelligence, connectivity, sensors, active engagement, and small device use. A brief review of these features is given below. AI. IoT essentially makes virtually anything smart, meaning it enhances every aspect of life with the power of data collection, artificial intelligence algorithms, and networks. This can mean something as simple as enhancing your refrigerator and cabinets to detect when milk and your favorite cereal run low and then place an order with your preferred grocer. Connectivity. New enabling technologies for networking and specifically IoT networking mean networks are no longer exclusively tied to major providers. Networks can exist on a much smaller and cheaper scale while still being practical. IoT creates these small networks between its system devices. Sensors. IoT loses its distinction without sensors. They act as defining instruments which transform IoT from a standard passive network of devices into an active system capable of real-world integration. Active engagement. Much of today's interaction with connected technology happens through passive engagement. IoT introduces a new paradigm for active content, product, or service engagement. Small devices. Devices is predicted have become smaller, cheaper, and more powerful over time. IoT exploits purpose-built small devices to deliver its precision, scalability, and versatility. IoT advantages. The advantages of IoT span across every area of lifestyle and business. Here is a list of the advantages that IoT has to offer. Improved customer engagement. Current analytics suffer from blind spots and significant flaws in accuracy and is noted. Engagement remains passive. IoT completely transforms this to achieve richer and more effective engagement with audiences. After that, technology optimization. The same technologies and data which improve the customer experience also improve device use and aid in more potent improvements to technology. IoT unlocks a world of critical functional and field data. After that, reduced waste. IoT makes areas of improvement clear. Current analytics give us superficial insight, but IoT provides real-world information leading to more effective management of resources. And the last is enhanced data collection. Modern data collection suffers from its limitations and it's designed for passive use. IoT breaks it out of those spaces and places it exactly where humans really want to go to analyze our world. It allows an accurate picture of everything. IoT disadvantages. Through IoT delivers an impressive set of benefits, it also presents a significant set of challenges. Here is a list of some its major issues. First one is security. IoT creates an ecosystem for constantly connected devices communicating over networks. The system offers little control despite any security measures. This leaves users exposed to various kinds of attackers. Next one is privacy. The sophistication of IoT provides substantial personal data in extreme detail without the user's active participation. And the next disadvantage is complexity. Sometimes IoT systems complicated in terms of design, deployment and maintenance given their use of multiple technologies and a large set of new enabling technologies. And the next one is flexibility. Many are concerned about the flexibility of an IoT system to integrate easily with another. They worry about finding themselves with several conflicting or locked systems. The next topic is IoT platforms. At this stage, we divide our IoT development into two parallel technologies: wearable and embedded. Developers can build apps for custom wearable devices like People, Samsung Gear, or can opt to create their own platform using embedded solution and then can develop apps for that platform. So in wearable platform, a large number of Android wearable devices are now being made and marketed. Smartwatches are getting popular by every day. Android Wear apps can be developed and tested in Eclipse. Another example is Google Glass. Salesforce is another platform which is coming up with awesome development environment, APIs in wearable technologies. Their solution is extended from Pebble to Google Glass. Now the second one is embedded platform. Arduino is the best starting point for embedded-based IoT. Basic Android boards don't come with Ethernet shield, and for Arduino to be able to work as IoT device, you need to select Android with Ethernet shield. Arduino Uno on the other hand is a board that comes ported with Ethernet shield, and so many different Arduino boards are also available in the market. And the other example of embedded platform is Raspberry Pi. Raspberry Pi is probably one of the best things to happen in DIY IoT. A wide range of data-driven applications like home automation server to home multimedia server, file server can be developed with Pi. Pi, like Arduino, has general-purpose I/O pins. But seamless working with sensors is bit tedious in Pi. Another example is Intel Edison board, which has integrated Bluetooth and Wi-Fi among host of other features. It supports wide range of industry standard hardware. What is important is it supports wide range of platforms including Arduino and Node.js. Next topic is cloud platform. Nowadays different cloud platforms are available. There are some most popular clouds like Google Cloud, Amazon Web Services Cloud, and Microsoft Azure Cloud. Let's rediscuss the possibilities to beverage vending machine once more in terms of sheer possibilities. In the conventional vending machine you need to press a button or put a coin to trigger the process of liquid flow, which stops after certain quantity. Now how about integrating PayPal or Google Money with the vending machine? How about a customer discovering the vending machine as website along with its location and then pays online for a glass of beverage? Once payment is successful, he gets an access token. He can pass the token to the machine through NFC and bingo. He gets his drink. Now the logical possibility is very important for understanding IoT. And IoT really can bring several services like online payment gateway, several hardware platforms like embedded board of the vending machine and smart objects and data like NFC GPS into a seamless environment. We will discuss it in brief. Now if you can integrate online payment into beverage vending machine, why not in a community washing machine? If you are using location service beverage machine, then why not utilize the location and payment service for the toll gate? Why not get the data of a medical diagnosis like ECG into cloud, such that several doctors can view it and form a comprehensive opinion about the patient's state? Well, in fact all of them are possible. A little understanding of web and software design would take your mind towards cloud. For instance, when you have to make a device discoverable in web, you have to assign a fixed IP address, maintain a router and follow several networking skills. You might not have the knowledge and infrastructure needed for maintaining a commercial sophisticated network for IoT. Yalla is a great example of what services and cloud can bring to table. This provides connection as a service such that your device is easily discoverable and communicable over the web without much hassle and take care of underneath security. Google has already integrated location services with its cloud. Location extended from your devices are silently put in your status updates in Facebook and Twitter and are also used for more personalized searches. So Cloud APIs has a great potential in IoT in all levels of architecture, starting from firmware to hardware to more top-level architecture. Now the next part is IoT hardware. The hardware utilized in IoT systems includes devices for a remote dashboard, devices for control, servers, a routing or bridge device and sensors. These devices manage key tasks and functions such as system activation, action specification, security, communication, and detection to support specific goals and actions. So first we will discuss about IoT sensors. The most important hardware in IoT might be its sensors. These devices consist of energy modules, power management modules, RF modules, and sensing modules. RF modules manage communication through their signal processing, Wi-Fi, Zigbee, Bluetooth, radio transceiver, and duplexer. The sensing module manages sensing through assorted active and passive measurement devices. Here is a list of some of the measurement devices used in IoT. Accelerometers, temperature sensors, magnetometers, proximity sensors, gyroscopes, image sensors, acoustic sensors, light sensors, pressure sensors, humidity sensors and many more. Next part is wearable electronics. Here are some wearable electronics gadgets name as mentioned. Wearable electronics devices are small devices worn on the head, neck, arms, torso and feet. Smartwatches not only help us stay connected but as a part of an IoT system. Current smart wearable devices for head is helmet and glasses. For neck, jewelry and collars. For arm, watches, wristbands and rings. For torso, clothing and backpacks. And for feet, socks and shoes are available. Now the next topic is IoT protocols. IoT primarily exploits standard protocols and networking technologies. However, the major enabling technologies and protocols of IoT are RFID, NFC, low energy Bluetooth, low energy wireless, low energy radio protocols and Wi-Fi Direct. These technologies supports the specific networking functionality needed for an IoT system in contrast to a standard uniform network of common systems. Now let's see in brief. RFID technology employs two-way radio transmitter receivers to identify and track tags associated with objects. NFC consists of communication protocols for electronic devices, typically a mobile device and a standard device. Low-energy Bluetooth technology supports the low-power, long-use need of IoT function while exploiting a standard technology with native support across systems. Low-energy wireless technology replaces the most power-hungry aspect of an IoT system. Low-energy wireless not only reduces power consumption but also extends the life of the device through less use. Radio protocols. Zigbee, Z-Wave and Thread are radio protocols for creating low-rate private area networks. These technologies are low power but offer high throughput unlike many similar options. This increases the power of small local device networks without any typical cost. Wi-Fi Direct eliminates the need for an access point. It allows P2P connections with the speed of Wi-Fi but with lower latency. The next topic is IoT applications. IoT has applications across all industries and markets. It spans user groups from those who want to reduce energy use in their home to large organizations who want to streamline their operations. It proves not only useful but nearly critical in many industries as technology advances and we move towards the advanced automation imagined in the distant future. Applications of IoT in these areas include improving production, marketing, service delivery, and safety. IoT provides a strong means of monitoring various processes, and real transparency creates greater visibility for improvement opportunities. The deep level of control afforded by IoT allows rapid and more action on those opportunities, which include events like obvious customer needs, non-conforming product, malfunctions in equipment, problems in the distribution network, and more. Let's understand by one example. Suppose John runs a manufacturing facility that makes shields for manufacturing equipment. When regulations change for the composition and function of the shields, the new appropriate requirements are automatically programmed in production robotics and engineers are alerted about their approval of the change. IoT applications in government and safety. IoT applied to government and safety allows improved law enforcement, defense, city planning, and economic management. The technology fills in the current gaps, corrects many current flaws, and expands the reach of these efforts. For example, IoT can help city planners have a clearer view of the impact of their design and government have a better idea for the local economy. Let's understand by one example. Suppose Joan lives in a small city. She has heard about a recent spike in crime in her area and worries about coming home late at night. Local law enforcement has been alerted about the new hot zone through system flags and they have increases their presence. Area monitoring devices have detected suspicious behavior and law enforcement has investigated these leads to prevent crimes. Applications for home and offices. In our daily lives, IoT provides a personalized experience from the home to the office or the organizations we frequently do business with. This improves our overall satisfaction, enhances productivity, and improves our health and safety. Let's see one example. Suppose Joan works in advertising. She enters her office, and it recognizes her face. It adjusts the lighting and temperature to her preference. It turns on her devices and opens applications to her last working points. Her office door detected and recognized a colleague visiting her office multiple times before she arrived. Joan's system opens this visitor's messages automatically. And the next application in healthcare and medicine. IoT pushes us towards our imagined future of medicine, which exploits a highly integrated network of sophisticated medical devices. Today, IoT can dramatically enhance medical research, devices, care, and emergency care. The integration of all elements provides more accuracy, more attention to detail, faster reactions to events, and constant improvement, while reducing the typical overhead of medical research and organization. For example, suppose Joan is a nurse in an emergency room. A call has come in for a man wounded in an altercation. The system recognized the patient and pulls his records. On the scene, paramedic equipment captures critical information automatically sent to the receiving parties at the hospital. The system analyzes the new data and current records to deliver a guiding solution. The status of the patient is updated every second in the system during his transport. The system prompts John to approve system actions for medicine distribution and medical equipment preparation. Thank you.